This is 11.52, true or false. CBr4 is more volatile than CCl4. And if you look, each one of these asks about CBr4 and each one of these asks about CCl4. And so the first thing you want to do when you encounter questions about volatility, boiling point, intermolecular forces, vapor pressure, is sketch the Lewis-Dot structure, because you want to know what kind of forces hold this guy together with more of these guys. And the same thing with this guy. You want to sketch him, because you want to know what kind of forces hold this guy together with this guy right here. And you can see that this is perfectly symmetrical, and so it is going to be a nonpolar molecule. Same thing with this guy right here. And so the only thing that holds this guy together are London dispersion forces and London dispersion forces. And the strength of London dispersion forces is based on the number of electrons that you have, because the more electrons you have, the more instantaneous polarization you can have. And then if those are equal, then it depends on the shape of the molecule. But you can see the shapes of these molecules are going to be exactly the same. They're both going to be tetrahedral. So when you add this guy up on the periodic table, you have 4 bromines, and then you have 1 carbon. You get 146 electrons. Whereas this guy right here, it's 17 times 4 plus 6 for carbon. That ends up being quite a few less. So 17 times 4 is 68, plus 6 more, we have 74 electrons inside this guy right here. So this one is definitely going to have the stronger intermolecular forces, because it's going to stick together because it has more electrons and more London dispersion forces. So we actually just answered C right here, and CBr4, this would be false because it has stronger intermolecular forces. CBr would have a higher boiling point then, because it would stick together. So we'll answer them kind of just randomly as we go. This one would be false. B would be true because it would stick together better than CCl4. CBr4 is more volatile than CCl4. That's not true, because CCl4 would want to go from a liquid to gas much faster because it has weaker intermolecular forces, so that one would be false. And then lastly, let's answer D. CBr4 has a higher vapor pressure at the same temperature as CCl4. So vapor pressure means that it can go from liquid to gas easier, and CCl4, with the weakest intermolecular forces, would love to go from liquid to gas a lot quicker than something with stronger intermolecular forces. So this would be false as well, because it would actually be the opposite. CCl4 has a higher vapor pressure than CBr4.